Hi friends! So in my last video, we learned about unity and how it is an important concept in set theory. Today, we'll learn about another important concept in set theory called characteristic. So let's get started. First, we need to understand what is meant by a characteristic. In mathematics, a characteristic is a rule or a property that can be used to describe or distinguish a set. In other words, it's a way to identify the elements of a set based on some specific condition or rule. For example, consider the set of natural numbers. We can describe this set by the rule or condition that generates its elements, which is the fact that every natural number is obtained by adding 1 to its predecessor. This means that if we start with 1 and add 1 repeatedly, we will generate all the natural numbers. So in this case, the generating rule add 1 to its predecessor is the characteristic of the set of natural numbers. Similarly, we can define the set of even numbers as the set of all natural numbers that are divisible by 2. In this case, the condition divisible by 2 is the characteristic of the set of even numbers. Now let's look at some examples. We can write the characteristic of set A as to n, where n is any natural number. This means that an element x is in set A if and only if it is equal to 2 times some natural number. For example, 2 and 6 are in A because they can be written as to 1 and 2 and 3 respectively. Similarly, 8 is in A because it can be written as 2, 4. But 5 is not in A because it cannot be written as 2 times any natural number. Example, no. 2. Consider the set B of all natural numbers less than 10. The characteristic of this set is n, where n is less than 10. This means that a natural number x is in set B if and only if it is less than 10. So 9 is in B because 9 is less than 10. But 10 is not in B because 10 is not less than 10. Example, no, 3. Let S take the set C of all prime numbers less than 10. The characteristic of this set is somewhat more complicated and can be written as divisible only by 1 and itself. This means that a natural number x is in set C if and only if it is divisible only by 1 and itself. So 2, 3, 5, and 7 are in C because they are only divisible by 1 and themselves. But 4 and 6 are not in C because they are divisible by other numbers as well. Now let's take some time to discuss the importance of characteristics. Characteristics are an important concept in set theory because they provide a way to characterize sets without explicitly listing their elements. This can be especially useful when dealing with infinite sets whose elements cannot be listed, such as the set of real numbers. By using characteristics, we can define sets in a more concise and general way, which can make it easier to reason about them mathematically. Additionally, characteristics can be used to prove set identities and other set-theoretic relationships. For example, we can use the characteristic of the empty set to prove that the intersection of any two sets is equal to the empty set. By using characteristics, we can avoid the need to list out the elements of the sets, which can be tedious and error-prone. Instead, we can simply manipulate the characteristics algebraically to prove our desired result. This makes set theory more elegant and powerful by providing a more concise and efficient way to work with sets. Okay, friends, that's all for today's video. I hope you found this video useful. If so, please like and share this video with your friends. And if you have any questions, feel free to comment below. I'll try my best to help you. Thank you for watching and see you in the next video.